Hello, math application students, and welcome to your online lesson. Today we'll be looking at roots as exponents. When we talk about roots, we're talking about square roots or cube roots, which are also often referred to as radicals. So our learning intention is we will learn to apply exponent rules with radicals or roots, and we'll know we're successful when we can efficiently solve IB level problems involving rules of exponents and radicals. So to start off today, we're going to look at this question. What does a to the 1/2 power times a to the 1/2 power equal? So a here is our variable. It's also our base. It's being raised to a power, and the power is 1/2. Now we know from previous lessons, an exponent counts up how many things are being multiplied. Well, half being multiplied. It's not immediately clear what this means. But if we use our rules that we already have from our previous lesson dealing with a power times another power, where we have two bases but they're the same, we know that we can take our exponents and do what? Well, again, if the bases are the same and we're multiplying, we should be able to simply add our exponents. And if we have an exponent of 1/2 and then another 1/2, if we add a half plus a half, we get 1 whole. So it's a to the 1, which is just to say we have a single a. There's another way, though, that we could look at this problem. If we have a to the 1/2 times the same exact thing, a to the 1/2, or times itself, we could simply write this as a to the 1/2 quantity squared, where a to the 1/2 is getting multiplied by itself. And now we have a power of a power, just a single base here, which is our variable of a. It's being raised to a 1/2 power, but then all that's being raised to a 2 power. So we know that when we have a single base with two exponents, we can multiply those exponents. And 1/2 times 2, or half of 2, just gets us back to 1 again. So we have a to the first power, or just a. All right. So then the question is, what is an equivalent expression to a to the 1/2? Or what does it mean if we take something to the 1/2 power? What do we really have here? Well, again, a is just a variable. It could be anything. But as we saw, if we took this a to the 1/2 and we squared it or multiplied it by itself, we ended up with just a. Well, what kind of number can we square that just becomes the number again? And the thing that we can cancel out essentially with a square is a square root. So if we had a square root of a and then we squared it, well, the square root and the square are opposites of each other, and they would cancel out, leaving just a. Therefore, we know that a to the 1/2 is equivalent or the same thing as the square root of a. And that's powerful because now we know that if we want to write something with a something that has a square root as an exponent, we can just make it into essentially a fraction of that whatever root we're taking. So again, a square root, we're taking, it's like a second root. We would take it to the 1/2 power. If we had something like a fourth root, let's say the fourth root of x, we could rewrite that as x to the 1/4 power. Quick reminder of what we mean by a fourth root. Well, that'd be something where you can multiply four things together that would equal that original value. So let's say x was 16, and we did the fourth root of 16. That would be the same thing as saying 2, because 2 times 2 times 2 times 2 would give us 16, because 2 times 2 gives us 4, times another 2 gives us 8, times one more 2 gives us 16. So then the fourth root would say, what can we multiply 4 of to equal the 16? And that would be 2. We formalize that here on this slide, where we have a to the 1 over n equals the nth root of a. And again, we could substitute that for really anything. So if I had a to the 1/7 power, that would be the same thing as the 7th root of a. Or we could plug in a number here. 2 to the 1/5 power is equal to the 5th root of 2. Working the other direction, like we did before, we could do the square root of x, and we know that that is x to the 1/2. And there's always an implied 2 right here if they don't write anything, so we assume it's a square root or a second root. And then we could do something bigger, like a 9th root of 7 would be the same thing as 7 to the 1/9 power. One of the things that's really valuable about this is all of our rules that we'd previously learned dealing with exponents, now we can basically apply those to any time we have any sort of radical or root. We can rewrite that as an exponent and then use any of those rules that we've already learned. What we've got here on this next question, what power is equivalent to the nth root of a to the m? So once again, a is our variable and our base. It's already being raised to the mth power, or a power of m. So we have a to the m power. But all of that is then being raised to the, or being like an nth root that we have here, which we know we can write as 1 over n. Well, now I've got a power of a power. So what am I going to do with these two exponents? These two exponents here, since there's only one base, are going to have to be multiplied. And we can just think of this as m over 1 and multiply straight across. So you'd have a to the m over n. So what's a simpler way to think about this? Well, if we look at any power, and let's just make up some other numbers here. Let's say we have a third root of x to the 5th power. Well, the power that the x has, which is a 5, can just stay there. So we have x to the 5th power, and the root just goes in the denominator. So we have x to the 5/3 power. Working the other way, if I had something like y to the 7/2 power, well, now the power is, or exponent is still going to be the 7 that we have here. And so we'd have y to the 7th, but the root that we have is a 2, so we would have a square root. So that would be the square root of y to the 7th. And we'll look at a few more examples in a few moments. So for these, we want to write as a single power of 2. So 2 to some exponent. On our first one here, we've got 2, which is our base. And we want to write this as a certain power. Well, it's a cube root right now. So a third root, we just write as 1 over 3. And that's that. For the second one, again, here's our base of 2. It's got a square root going on, so we could write that as 2 to the 1/2 power, because again, there's always this implied 2 here if nothing else is written. However, it was in the denominator. And since it was in the denominator, that means that our exponent must have been negative. So we have 2 to the negative 1/2 power. Once again, the 1/2 is what makes it a square root over here, and the negative is what puts it in the denominator. Now part C, to start with, there's nothing fancy going on here. We could write 4 to the 1/5 power. 5th power, because we had a 5th root going on here, so we just put 1 over 5 for our exponent. However, it's saying in the directions to write as a single power of 2. So then our question is, how could we write 4 as a power of 2? So 2 to what power equals 4? And that one's pretty obvious. I think we all know that if we take 2 times another 2, or 2 2's, we would get a 4 here. So what I could do is I could essentially replace this 4 here with a 2 squared, and then all that's getting taken to the 1/5 power. And now if we multiply 2 times 1/5, we would get 2 to the 2/5 power. And that would be our final answer for that one. One of the reasons we like to write things as powers is because we can punch them in the calculator pretty easily, as opposed to writing them as a radical or a root where you have to go to a bunch of menus. So if we have something like 2 to the 7/5, we should be able to get that into our calculator pretty easily, and we're going to demonstrate that right now. So on the calculator, if I want to find 2 to the 7/5 power, I type in my base of 2, and then I type in the caret, which we've done previously for quadratics and things like that to get a squared, but now we're most likely going to be typing in some sort of fraction. So I press the caret key, it raises my cursor up on my calculator display screen, and now I'm going to write a fraction. And to do that, I'm going to write division. So I'll have 7 divided by 2, which gives me those 7 divided by 5, sorry about that, which gives me the 7/5 that we originally had there. And then I can hit enter, and I end up with a decimal equivalent of approximately 2.6. And again, we want to round to our third significant figure. So 1, 2, 3. We're going to round that 3. Since there's a 9 that appears after it, we're going to round up. So it'd be 2.64 for our final rounded value of that. Now let's try doing it for our second one here, part B. We have 1 over the cube root, or third root, of 4. To start with, let's write it as a power, or using exponents. So 4 is our base. It's got a root of 1/3, but it was in the denominator, so our exponent has to be negative. So negative 1/3 is our exponent. Our base is 4. So we're going to type that in the calculator here. And so we have 4 to the negative 1 divided by 3. So 4 to the negative 1/3 power. Hit enter. We get 0.6299. Now when I do the rounding here, our third significant digit is this first 9, but there's another 9 after it, which means this is going to round up to a 10. We carry the 1, so we have 0.630 is what we're looking at there. So our answer, 0.630. I want to point out, though, despite the fact that there was a negative exponent here, just a reminder from our previous lesson, that does not change the actual value of our answer. Our answer is still very positive. A negative exponent just means we're dividing rather than multiplying, and the calculator answer confirms that. All right, the last thing we're going to do here is we just want to simplify these things. Simplest rational form, which means if we need to write it as a fraction. So I've got 8 to the 4/3 power. Well, what we may want to do is turn this back into a radical. So I've got 8 as my base. My exponent is 4. And then I've got the root that is the third root. Now, the nice thing about roots and exponents in the gamma or PEMDAS order of operations, they're equivalent. You can do them in either order. So if we wanted to, we could first do the cube root of 8 and then take it to the 4th power, which would actually look more like this if I wrote it. You know, do the cube root first and then take it to the 4th power. Or, like it's kind of written here, I could do the 4th power first and then do the 3. Well, if I'm not reaching for a calculator, let's make it smaller before we make it bigger so we don't have to deal with such large numbers. So personally, I'm going to work with this second version here, which says do the cube root of 8. So we're asking ourselves, what number can we multiply 3 of them where they would end up being an 8? And 1 times 1 times 1 would give us 1. The next biggest number is 2. 2 times another 2 is 4 times another 2 is 8. So the cube root of 8 is definitely 2. And then we still need to take it to the 4th power. Well, 2 times 2 times 2 times 1 more 2 would get us up to 16. So this entire value is 16. Now we could check that on our calculator. And that, I could go back to the original 8 to the 4/3 power. And I get 16, which is the same thing we did without the calculator there. All right, let's do one more. So now we've got 27 to the negative 2/3 power. So let's write this as 27 to the third root. How did I know it was the third root? Because the 3 was in the bottom, or the denominator of the exponent. And then all of that is getting squared. Now again, I could have written that squared inside the radical with the 27, but I want to make this thing smaller before I make it bigger. And then the one other thing to notice is we've got a negative sign here, which means all of this has to be in the denominator. So I'm squeezing this all under a 1 there. So the cube root of 27, what number can we multiply 3 of to equal 27? And we did 2 times 2 times 2, or 2 to the 3rd power, gave us 8. 3 to the 3rd power, we'd have 3 times 3, which is 9, times 1 more 3, which would give us 27, because 9 times 3 is 27. So the cube root of 27 is 3. And we're going to take all that to the 2nd power, or square it. It's all in our denominator. And so we end up with 1 over 9, or 1/9 is the same thing as 27 to the negative 2/3 power. All right, and that is our lesson for today. Till next time.